Hello, myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. Welcome you to the fourth chapter, part 3, Radar Fundamentals of the subject Microwave and Radar. In this presentation, we'll cover up the antenna tracking types and principles, in which we'll study about sequential, conical and monopulse method. Then 4.5, that is antenna feed mechanism, particularly the Horn and the Cassegrain feed antenna mechanism will be studied. The course outcome is to interpret radar based systems for range detection. So the antenna tracking, after antenna has detected a target, that is, after having acquired a target by scanning method, the next job is to locate it accurately with respect to azimuth, with respect to range, and so on. So an antenna, even an antenna with a 1 degree error in its location by antenna of pencil shaped narrow beam, may miss the target at a distance 10 km away from the radar set by 175 meter. So accurate location of the target has to be very precisely determined from the echo pulses. So hence auxiliary method of tracking or precise location must be employed. For that we have the 3 different types. Let's see one by one. The first scheme is lobe switching method, that is also called sequential lobing, which is simplest method of antenna tracking. In this method, the antenna beam is rapidly switched between 2 positions, position A, position B down. So first diagram we see the lobe switching. The pencil shaped beam is radiating from the antenna feed point or from the reflector with 2 positions, position A and B. So it is switching between 2 positions, unless, so that the echoes will fluctuate at switching rate unless the target is exactly in midway and thus tracked accurately than merely pointing antenna at the target. So just only by pointing the antenna at the target will not give much detail. If we are switching between 2 positions, then we can locate the target in the mid, so that strength of the echo from the 2 positions are of equal strength. So in this way it is positioning, it is locating the target. The second method is conical scanning. The conical scanning, in this method, a parabolic antenna is mounted slightly off center and then rotating it about the axis of the parabola. The rotation is slow in azimuth compared to the PRF, pulse repetition frequency. Remember, the pulse repetition frequency is 1 upon PRT, and PRT is the pulse repetition time, that is the time between 2 pulses transmitted, or between 2 pulses the time interval is the pulse repetition time, and reciprocal of that is PRF. So the surface area described in space by the pencil radiation pattern of the antenna, the tip of the pattern moves in a circle. So the area described is conical with respect to the position of the antenna, and the area described by it is circular at a certain distance. So it forms a conical shape. That's why conical scanning. Advantage of this conical scanning is that it is accurate in elevation and azimuth. With respect to azimuth elevation, and azimuth means direction, so it is giving accurate measurement from the echo pulses. Sequential lobing advantage of it is that it is accurate in only one plane. The drawbacks, demerits of the sequential as well as the conical scanning, we find it is more complex motion because it is moving in, it is rotated about its axis at certain speed, and it's also rocked about moving up and down nodding. So that is a complex motion of the antenna, and for that servo mechanisms are required. Number 2 is more than one returned pulse is required to locate a target accurately. For example, in conical scanning we require minimum 4 echo pulses. So these are the major drawbacks of the conical and sequential tracking method. So if the target, particularly if the target cross section is changing, for example it is moving, the target is moving, or different part of the target is exposed to the incoming pulses from the radar set, then the echo power will be changed too. So we require the ideal system that would be one in which all the information obtained by the conical scanning could be achieved with just one single pulse and is called monopulse. So since the term indicates monopulse, with single pulse we are determining the number of informations from the received echoes. So here is the schematic diagram of feed arrangement for monopulse tracking. The monopulse tracking is actually amplitude comparison system in which there are 4 feeds, which are the horn antenna feed mechanism used, displaced about central focus. It is not located exactly in the center but is displaced about central focus of one paraboloid reflector. So paraboloid reflector is 3-dimensional structure like a ball. So that is a reflector used. Then transmitter feeds the horns, the 4 horns A, B, C and D simultaneously with the same power, so that a sum signal, when it comes out from the 4 feeds, is transmitted different from the usual pulse transmitted by a single horn. Whereas in reception or during reception, a duplexer using rat race ring, that is one of the waveguide section we have covered in the first chapter, that can be used as a duplexer, and it provides the following 3 signals. What are those? It provides the sum signal, that is A plus B plus C plus D, which will be providing general information of a radar receiver from the target. After receiving the signal from the target, it gives the general data. The second is the vertical difference, that is A plus C minus B plus D, and the horizontal difference A plus B minus C plus D, that is the horizontal difference. So these difference signals will be used for, or will be used as error signal, and will give more information about the target. So each of the 4 feeds produces a slightly different beam from the one reflector, so that in transmission 4 individual beams step out into a space. So 4 different, it is like similar to 4 different signals transmitted out into the space, into the towards the target. So no difference will be recorded if the target is exactly in the axial direction of the antenna. So if the target happens to be in exact on the central axis of the paraboloid reflector of the antenna, then all the three signals will be same. So, whereas once the target has been acquired, has been detected, any deviation from the central position, central axis of the dish or reflector will be shown by the presence of a vertical difference signal or a horizontal difference signal or both. So if the target is exactly in the center on the central axis of the dish, paraboloid dish, then there is no difference. Otherwise it will have the either vertical difference or horizontal difference or both difference signal will be there. So the receiver has three separate input channels, the sum signal and the vertical and horizontal difference signals, and one for each of the three signals, consisting of, now the receiver circuit consists of three mixers with a local oscillator, common local oscillator for demodulating the received echo pulses. It will have three IF amplifiers to bring down the received signal to intermediate frequency level, and then the three detectors. The output of some channel provides general data, as already discussed, of a radar receiver, while the difference or the error signals feeds is servo amplifier and motor. It is given to the difference signal or error signal is given to a servo amplifier or a motor that will drive the antenna so as to keep it pointed exactly at the target in order to aim anti-missile guns or electronic countermeasures. Advantage of monopulse tracking method: firstly, it obtains with single pulse the information which requires several pulses in case of conical scanning. It is not subjected to errors due to variation in target cross section, as it makes use of three received pulses, three channels. And the disadvantages includes, since we require two extra receiving channels, that is additional cost and is expensive, and designing the monopulse antenna is complex, duplexer and feeding arrangement, all these makes it more complex and bulkier, heavier. Now let's see the microwave antenna. The horn antenna we have already seen. An antenna converts an electrical signal into electromagnetic wave and vice versa, that is electromagnetic wave, parallel incoming wave are focused to a focal point, that is the feed point, and from feed point it goes to the receiver. So horn antenna, by connecting a horn at open end of a waveguide, this introduces a blunt discontinuity in changes to a gradual transformation. And when impedance is properly matched, then energy traveling in waveguide is radiated with improved directivity and reduced diffraction. So types of horn antenna we have seen also earlier: sectorial, pyramidal and conical types. Exponential type is also there. And the second classification is Cass horn antenna and hog horn antenna, that is based on the feed mechanism. So both these Cass horn antenna and hog horn antenna are low noise antenna used in satellite tracking and communication stations. So here we see the different horn antenna shapes. A is the pyramidal type, B and C are sectorial type, and D is conical type, and E is the exponential type. So out of these, E type, exponential type, is more efficient as there is a smooth or gradual change of the dimension, whereas the A to D structure, we see there is abrupt change from rectangular to flaring portion or conical portion. Now the Cassegrain feed antenna, it is named after the famous astronomer who showed that incident parallel rays or electromagnetic energy can be focused to a point by employing two reflectors. First, the primary reflector, that will be a paraboloid, and secondary reflector, that could be a paraboloid or hyperboloid. Here we are making use of hyperboloid, hyperbola, that is a convex reflector, a secondary reflector. So feed is placed usually at or near the vertex of the main reflector, that is one of the midpoint on the main reflector dish. Rays from the feed, so feed is located on the dish side, main dish side. So rays from the feed illuminate the secondary reflector, the convex reflector, and are directed towards the main reflector as if rays originated from the focal point of the primary reflector. So if we take the focal point, the virtual focal point will be just behind the, or it will coincide with the focal point of the hyperboloid reflector. The rays are then reflected by main reflector and comes out parallelly and propagate as plane wave front. So after reflection from the secondary convex reflector, it is impinging the main primary reflector, and from there parallel rays or parallel electromagnetic waves will travel into the space as plane wave front. The focus of secondary reflector coincides with the focus point of primary reflector. So there could be a blockage region behind the secondary reflector. What are the advantages? The advantages include the feed can be placed in a convenient location, as we can see in the adjacent diagram. The capability for scanning and or broadening beam can be achieved by moving one of the reflector, either the secondary reflector or the primary reflector. Thirdly, the transmitting or receiving equipment can be placed behind the main reflector, the primary reflector, the dish, that is parabolic reflector. Applications where it can be used in satellite ground based systems where pattern control is needed, where scanning is controlled, movement is controlled. So here are some review questions that is more frequently asked in board's paper. The references one can go through for further detailed study. Thank you.